Welcome to solverfy.
We are given a recurrence relation with initial conditions. We are asked to use generating functions to solve this relation. The recurrence relation is ak is equal to 4ak minus 1 minus 4ak minus 2 plus k squared. With initial conditions, a0 equals 2 and a1 equals 5. Suppose that g of x is the generating function for sequence ak. Then g of x is equal to the sum from k equals 0 to infinity of ak x to the k. This is equal to a0 plus a1x plus the sum from k equals 2 to infinity of a sub k x to the k. And by the recurrence relation, this is equal to a0 plus a1x plus the sum from k equals 2 to infinity of 4ak minus 1 plus or minus 4ak minus 2 plus k squared x to the k. And this is equal to a0 plus a1x plus 4 times the sum from k equals 2 to infinity of ak minus 1 x to the k minus 4 times the sum from k equals 2 to infinity of ak minus 2 x to the k plus the sum from k equals 2 to infinity of k squared x to the k. This is equal to a0 plus a1x plus 4 times, and then substituting k plus 1 for k, we have this is the sum from k equals 1. In fact, I'll just write it this way: 4 times x times the sum from k equals 1 to infinity of ak x to the k minus 4 times x squared times the sum from k equals 0 to infinity ak x to the k and plus, now we substitute t equals k minus 2, so we get plus, or instead of t equals k minus 2, simply write this as the sum from k equals 0 to infinity of k squared x to the k minus, and then 0. This is simply 0 times 1, which is 0. If k is equal to 1, we have 1 squared is 1 times x to the first. So this is minus x. This reduces to a0 plus a1x plus 4x times, we have that this is equal to g of x minus when k equals 0, which is simply a0, minus 4x squared times g of x, and plus sum from k equals 0 to infinity of k squared x to the k. Now, in order to find a more concise form for this sum, consider that k squared, this is going to be equal to the sum from k equals 0 to infinity of k times k minus 1 over 2 times 2. This is k times k minus 1. And we're going to subtract from that or add to it k minus 1. And so now we have k times k minus 1 over 2 times 2 plus k minus 1. This is going to be k plus 1 times k minus 1. A difference of squares. This is k squared minus 1. So we want to add a plus 1. So now we have k squared minus 1 plus 1, which is going to be simply k squared. So that's how we get from k squared to this expression. Times x to the k minus x. This is equal to a0 plus a1x plus 4x g of x minus 4a0x minus 4x squared g of x. And this becomes plus the sum from k equals 0 to infinity. And this is going to be k times k minus 1 over 2. Well, this is k factorial over k minus 1 factorial, or k minus 2 factorial times 2 factorial. So this is really the sum of k choose 2 times 2 plus, and then k minus 1. This is simply k minus 1 factorial, or choose 1. And then plus 1. We don't have to write it this way. We can keep it as k minus 1. And this is equal to a0 plus a1 minus 4a0 x plus 4x g of x minus 4x squared g of x plus 2 times the sum from k equals 0 to infinity of k choose 2 x to the k plus the sum from k equals 0 to infinity I might have made a mistake here, so going back, over here this says k equals 1 to infinity. This is simply from k equals 1 to infinity. And so this is from k equals 1 to infinity of k choose 2 times 2. So this last expression here is from k equals 1 to infinity of k choose 2 x to the k plus the sum from k equals 1 to infinity of k minus 1 x to the k plus the sum from k equals 1 to infinity of x to the k minus x. And this is equal to a0 plus a1 minus 4a0 x plus 4x g of x minus 4x squared g of x plus 2, and then this binomial coefficient tells us that this is going to be I made a mistake. This is the same as, instead of k choose 2, I can write this as k choose k minus 2. And we have, by a formula from the book, that this expression is going to be after I factor out an x squared, this is equal to the sum from k equals 0 to infinity of k plus 2 choose k x to the k plus, and this is going to be k minus 1 x to the k. This is the same as 1 over one minus x squared. We can also factor out an x, so we get 1 over x minus 1 squared, just the same, and then add to that 1 over 1 minus x, and so we get this is equal to a0 plus a1 minus 4a0 x plus 4x g of x minus 4x squared g of x. And this is going to be, we have plus 2 over 1 minus x cubed plus 1 over 1 minus x squared plus 1 over 1 minus x, which is equal to a0 plus a1 minus 4a0 x plus 4x g of x minus 4x squared g of x. This is equal to plus the least common denominator is 1 minus x cubed. So we have 1 minus x squared plus 1 minus x, and we have 2 plus 1 minus x plus 1 minus x squared, and this reduces to x squared minus 3x plus 4 all over 1 minus x cubed. And so we can solve for g of x. So we have that subtracting 4x g of x and adding 4x squared g of x to both sides, we get 1 minus 4x plus 4x squared g of x is equal to, this is a0 plus a1 minus 4a0x plus x squared minus 3x plus 4 over 1 minus x cubed. And so we have that g of x is equal to, if we plug in a0, a1, where a0 is 2 and a1 is 5, we have 2 plus 5 minus 8 is negative 3x, plus x squared minus 3x to the fourth over 1 minus x cubed, all divided by 1 minus 4x plus 4x squared. And this reduces to 3x to the fourth minus 11x cubed plus 16x squared minus 12x. All over, and this is going to be 1 minus x cubed times 1 minus 2x squared. And in order to find the terms for the sequence AK, we need to use partial fraction decomposition. So we have that, say this is equal to a over 1 minus x plus b over 1 minus x squared plus c over 1 minus x cubed plus d over 1 minus 2x plus e over 1 minus 2x squared. And to solve this system of equations, we'll use a computer algebra system. Since it's a system of 5 equations and 5 variables, it'll take a very long time. And we get that a is equal to 29, b equals 9, c equals 2, d equals negative 113 over 2, and e is equal to 45 over 2. And plugging in these values, we get the expression of g of x in terms of these sums. And so we have that g of x is going to be equal to after doing this and converting these sums using the formula from the book, we find that the sequence member AK is given by 29 plus 9 times k plus 1 plus 2 times 2 plus k over k minus 133 over 2 to the k plus 45 over 2 k plus 1 to the k. And this is our answer.